Всі-
Вітаю на каналі Код України, де ми вкотре проводимо моки. Сьогодні Вікторія підготувала для мене задачку. От, і я буду її розв'язувати. Кажуть, що задачка хард, тому будемо дивитися, чи вийде. От. Ну, все.
Сподіваюсь, буде цікаво.
Alright.
Так. So, hello, Nikita. How are you
Hello.
doing today?
Doing good. Not much has changed. Yeah. Right.
Oh,
I think I can
it's
just jump straight into the problems since
sure.
it's for the video.
So, the problem is called minimum window substring. So, you're given two strings of different lengths, and so we are given two strings S and T. And we want to return the minimum window substring of S such that every character in T, including the duplicates, is included in that window. If there is no such string, we just return an empty string.
All right, so I have a couple of clarifying questions about that. So a window substring, it just means like any substring of consecutive characters, right?
Yes.
So I need, and you said including duplicates, so I think it will be easier to ask on an example. Let's say we have Abba Saba, and T, for example, is Abba. Right, so I believe that the answer, the output, will be BACAB. Is that like, because it's the shortest substring that has two A's and two B's? Is that what we are doing?
Yeah.
So we have to find like every letter with the corresponding multiplicity, so to speak.
Yes.
The number of times a character occurs in the substring of S should be at least that of within T.
Yes.
And it is okay to have extra characters.
Yes.
Okay. Do I return the substring or the length of the substring?
You return the substring itself.
Okay, the substring itself. All right. And minimum just in terms of length.
Yes.
What if I have two substrings of the same length that both satisfy the problem?
So the
Okay.
test cases that you're gonna get don't have that. So we assume that there is a unique solution, and in test cases there will be only unique solution.
It's unique. All right, so I don't have to worry about the tie breaks and such. Now about a couple of questions about strings, just real quick. They can be like pretty long, right? A couple 100,000 characters, something like that.
Yeah, couple 100,000 is a good approximation.
Okay. And also, the characters are just lowercase English letters.
Or uppercase.
Or uppercase. So I can have both lowercase and uppercase. Should I treat them as the same character or as different?
No, as different characters.
Okay. Great. In that case, I will just assume that we can have arbitrary characters because it's not easier. All right. So let's start with something very naive for this problem. I will denote n as length of S and m as length of t. In this case, we can check, iterate over all substrings of S. There are O of n squared substrings. Iterating over is like, on average, a substring of S has length n over 3. So iterating over it is another factor of n for a total of O of n cubed. And this is what it takes to iterate over all substrings and over all characters within each substring. And we iterate over all characters within a substring to compute the frequency of each letter and just check. If for all letters the frequency is at least that of t, we can pre-compute the frequencies in t at some point. And then a substring is good. If it's not, then it's not. And once we know for each substring if it's good or not, we can select the shortest one. Obviously, this is very inefficient. Just like brute force.
It was an option, yeah, but
there is a silly way to do this. Right. So here, for each substring, we had to iterate over all of its characters to compute the frequencies. Right? It's not necessary. There is a way to avoid this factor of n. It's called prefix sums, or in our case, frequencies. Like if we can compute for each, I'll call it dp, but it's not necessarily computed as a dp. So for each prefix, for each letter, compute the frequency of this letter on this prefix, right? Then in S from left to right, the frequency of this letter is equal to dp right letter minus dp left letter. Right? There is this equation. You like take a big prefix and then subtract whatever you don't need in this part. So that would allow, if we pre-compute this, and we can do this in O of n times alphabet size time, right? Because there are only that many letters and only that many prefixes. And then we can calculate these frequencies in constant time instead of n. So what it will be, we still iterate over O of n squared substrings, but now each frequency we calculate in constant time, but we need to calculate big O of alphabet of them. So that is big O of n squared times alphabet size. This modulo denotes size in mathematics. Well, in our case, it's like 52. 26 plus 26, the number of unique characters that can be. Right, this is still inefficient.
How many did you say?
Come again?
How many did you say again?
52, right? 26
oh, yeah.
plus 26.
Yeah, I misheard.
Just like playing cards. Right. Why is this inefficient? Because we are checking every substring, right? It doesn't make sense. For once, it doesn't make sense to check strings that are super short, right? Because if the string has less than m characters, then surely it can't contain all the frequencies, at least that of t. So one way to use this idea, to leverage it, is to say, well, what if you think like for a fixed length, can we answer, is there a substring of this length that has all the required frequencies for a fixed length, right? So we pick some length k, and then we look at all substrings of this length, and we see, does any of them work? Yes, no. If it does work, then it means that the shortest substring that works is less than or equal to k. If it doesn't work, it means that it's greater than k. So what does it mean actually? It means that we can use binary search over the length of this string, right? There are only n possible lengths, so binary search will terminate within log n iterations. Now what does each iteration do? It considers big O of n strings of this length, and for each of them it applies this algorithm with pre-computed prefix sums. So that would improve upon previous one as follows: n log n times alphabet size. Right? It is still not optimal. We can do better. Next thing we can use is we consider all of these strings separately, as if they have nothing to do with each other. Now that is not true. When we consider s from 0 to k, and then we consider s from 1 to k plus 1, this is almost the same string, especially in terms of character frequencies, right? So the only thing that changes is that frequency of sk plus 1 is increased by 1, right? It's incremented. And then frequency of s of 0 is decremented, right? So we can just compute frequencies here once in O of k time, and then for each next string we can transition from one to another in O of 1 time, right? So it means that we no longer need this nonsense with pre-computed prefix frequencies and looping over all characters. Well, technically we may have to do this, depending on how we check if our frequency table is good enough or not.
Oh, you're breaking right now.
Oh, I'm sorry. So what I was saying is...
maybe if you...
Yeah. Like it depends on how we
Are
use...
you breaking again? Yeah.
I can switch to a different network. Is it still bad?
Maybe. Well, I can hear you, but there's obviously quite a bit of a delay between us.
Okay, then let me quickly switch. Let's try this one. Once it unfreezes, should be good. No? Okay. I did not expect this. Oh, it's recording. Okay, but it is not sharing. And also, I'm not sure if
If
now
it helps, Okay, now you're sharing.
Right. I hope the recording will be safe in split in parts. All right, so now I'm not breaking up, nothing like that, right?
Yeah, now it's better.
Okay.
Yeah.
So what I was saying is this idea of a sliding window, right? Fixed length, sliding window. We can take our complexity down to O of n log n. We still do binary sort, but for a fixed length, we just use a sliding window of a fixed length and process updates to frequency map.
So you're saying that we do a binary search to find the length of the window, and then we fix the length and do the sliding window.
Right.
Mm-hmm.
Now, it is still not optimal. We can just do a variable length sliding window as follows. So we will extend our window to the right. I'm not sure if that is right for you, but it's right for me. Until it contains all the necessary characters. So we'll start with 0, 0, extend right until it contains all the characters. Now we try, we think maybe we just included too much on the left, like there is some nonsense, letters we don't need. So we start moving left one by one. If we removed some characters that we did not need, then, well, that's good. We now have a shorter string. Right? If we remove something important, then our right will move further. Once again, until it does not contain all the necessary characters. With necessary frequencies. So this is basically our idea. We will have like a hash table from letters to how much of this letter we still need. Right now, depending on how we implement it, it will be either of n or of n times this alphabet size, right? I will just show the O of n implementation. We will not do this if you don't mind. Because it's a big constant. It's technically a constant, but it's a big one. It's like 52, right? So this is why I included in all of our analysis.
So you're saying that you can implement the sliding window approach and get either one or the other complexity?
Depending on how we implement it, yes.
Okay. And what exactly is n in your case?
N is, well, okay, fair enough. N plus m, and here, but here you will have just m. Yeah.
Okay. And how about the memory complexity?
Of alphabet size. We have a hash map where keys are letters, so there are not more than alphabet size keys.
Okay, and for the sliding window, you only keep the indices.
Of course.
Okay. Sure, let's implement then. You want to implement the more efficient one, right? The O n plus m.
Yeah, it's not much harder to implement. It's like, as I said, we will store how much we still need instead of how much we have. This way we can compare with 0 instead of comparing with the value of t.
Yeah.
T. Right, I would like to use C++ for this task.
Okay, good choice. I cannot help you with C++.
Well, at least with the signature of the function, or should I come up with one myself? Like I can.
Yeah, sure. That I can do. I can just copy paste you the.
Yep.
Okay, that's all the help you're getting from me for C++.
Fancy colors. Yeah, sure. That is a big tab for C++, but okay. So as I was saying, we want this lens probably. It will be difficult to live without it. We want a frequency table from characters to integers. It will be just C and T. Right? Is it really a string? Okay.
Yeah.
Anyways, doesn't matter. Here broke. Okay. So first things first, we store how that we need this character, right? For every character of T we record, we need one more of this character.
Okay.
Right. Another thing we'll store is how many characters we still need. That will be like number of positive values within this map. So here, if we did not have this character previously, then we increment the number of the characters that we lack at least one of. Because to achieve this efficient check, I need to keep track of this quantity, because I don't want to iterate over the entire map. If I iterate over the map, then it will be this alphabet size multiplier. So I'll just keep track of it. Now we can do our sliding window. Left 0, right 0. Answer. I'll keep like best L, best R.
Why do you want to keep the indices instead of just the length itself? Oh, because you want to return it, of course.
Yes, I want to return the string instead of the length. That will be just substring from best left, and here we don't actually provide best right, we provide the length. So maybe that was a good idea to have best len. Okay. How does our sliding window look? I said it the other way, like we move right while something doesn't hold, and then move left one by one. In the actual implementation, it is simpler to do it the other way, I think. Just move right one by one, and then move left while we can. So what does it mean while we can? First of all, what happens when we move right? We decrement, we now have one more of SR, right? So we decrement our need. If we no longer have need in this character, we decrement the number of unique characters that we still lack, right? Like we fulfill the need for this character, we have one less character to go. Maybe it's more reasonable to call it like unique, but positive is, once again, in turn, how many positive values are there in the map. It also has a semantic meaning. So here what I say is, while not positive, like while all needs are fulfilled, right? All frequencies being negative or 0 means that we have enough. We started with something positive, we subtracted enough to have all the necessary characters. Hopefully that makes sense. So while this...
So I'm just wondering about this positive number where you define it here. So it looks like you count the number of distinct elements that you need, right?
Yes, that's why I said that it
Here?
may make sense to call it unique, number of unique characters that I need. And here I say I no longer need this character. Not only I need one less of this character. Right? For example,
yeah, exactly. So you need one less.
2, right? If I needed 2 and subtracted 1, I still need it. So this doesn't happen.
Oh, okay.
But if I
Yeah,
had
got
1
it. You have
subtracted
to check.
0, then I don't no longer need. And more importantly,
Yeah,
if
makes
I
sense.
already had like 0, I subtracted -1. I will not do this again. Like if I already fulfilled this character, then I won't subtract twice or anything like that. So it's like literally the number of positive keys in positive values in the map.
Yeah,
So
okay, makes sense.
So while not positive, positive cannot be negative, so it's like 0 or positive. So it means that our length is good. Right? So let's try maybe removing s of left. And removing actually corresponds to incrementing the frequency. Because the way we did it here. So now if after removing, no, actually I believe this way. If before removing we had 0 need in this character, and now we increment it, it also corresponds to incrementing the positive. Okay. We had this letter covered, but we tried to move left, and it no longer works. So we have to increment this positive. And here I also have to move the left, actually. Like if I successfully move the left, then left goes to left +1. This is just +1. Right. So here, after I break from the loop, it's obviously because of this. Right? So the previous value of left was good, but now it is not.
You mean was in T, but now it's not.
Yeah, so like s from left -1 to right inclusive actually was good. Inclusive because I did this, but now it's not. So best length here is probably should not be initialized with 0. Now that I think about it, probably should be like some sentinel like n+1. So here what do I want to say is you know what, it's probably safer to say it within the conditional. I usually do it after, but in this particular problem it may be better to say it here. So let's compute the length of this. The length of this should be this, right? Both left and right are included at this point. So if length is less than best len, then I update best len to len, and also best left to left. Make it more this way. Because both left and right are included, so I need +1. And you said I don't have to worry about type breakers, so I just compare the lengths.
Yeah. Yeah.
And so then here I would have to check if best length is equal to n+1, and I would return an empty string. Otherwise, I would return the actual substring. Because I cannot take like from 0 n+1 characters. I don't have n+1 characters. So that would be an error. So I have to use this. check. Looks legit. Probably should run it on some tests or something. We had this one. We can do it on this one, or we can do it on your case.
Sure, whatever you prefer. We can also do it on that one. I think it was an interesting case as well.
On which one?
I'm just on yours.
Okay, but there are like.
But I'm
okay.
fixed.
Let's do it on your case.
I'm still.
Yeah.
So what it does, it checks if the element where we have the left index
It was 0.
is present is 0. What happens
0.
if it's not in the map at all?
In C++, it works like a default dict. Oh, you mean?
Okay.
Hold on. Well, not real. Like, if it's not in the map, this value will be 0. But I don't think that it can be not in the map. Yeah, but okay, let's think about this. I think here it will subtract unnecessarily. Like here it will actually, or maybe not. No, yeah, I think it doesn't matter because if a character is not in T, what we store in our map is frequent. For letter, we store frequency in T minus frequency in substring of S, right? And if it's not in T, then this is 0. So this entire value is never positive. So it should not influence our modifications of pos. Like we do process it, but
So
yeah.
So what you're saying is that this map count is going to store all the elements that are in S? Because my understanding was that it only stores elements that are in T that we're interested in.
No. For every character, be that in T or S or even other characters, when you try to access it, you get frequency in T minus frequency in substring.
Okay, so it only has elements that are in T, right? That's correct.
No. It can have both. Just like frequency in T, maybe 0, if the element is not present in T.
Okay, maybe once we go over example, it would make a bit more sense to me.
Sure. I would like to go over your example if you don't mind.
Sure. Okay, let's start with this example. Are comments like this in C++?
Well, this is very long.
Yeah, we can actually just, we can,
no, we can do it. We can do it with this. Okay, let's just do it with it.
You can also do it like this if you want.
It makes sense. There are still several windows. Okay.
You can also remove like a few extra ones.
Let's just, this works. Let's go over this one. So what I have is positive count, left, right, n, best left, best len at some point as well. Yeah. So we start with what? We start with saying that positive is equal to 0. And we iterate over characters of t. Now we also initialize this empty dictionary. We iterate over letters of t. We say, hey, look, we got a letter of A. Is A in this map? Like, has it any frequency? If it's not in the map, then by default, this square brackets operator will return 0, or rather, like default value for the second type, which happens to be 0. So we will increment positive, and then we will increment for A the value in the map. In a similar fashion, we will add B and C to the map. Now the map looks like this. Right? And positive is at 3. And gets initialized to like 8, I believe, code bank. No, 7, code bank. Okay. Left is 0, right is 0, best L is 0, best len is 8. So what I say, right is 0. I look at S right, so at letter C. I decrement its frequency in the map, so it is now 0. It is now 0, so I hit this if, and I say, oh look, I have one less character with a positive value in the map, so positive decrements to 2. While not positive, well, positive is 2, so we don't go in within this while loop at all. This while loop processes valid windows. We don't have a valid window yet. We still lack some characters. So now right equals 1. I go to letter O. I decrement the frequency. So now by default it was 0. Now it's -1. Is it 0? No, it's not 0, so I skip the if. So positive is unaffected here, because this is -1. Not -1 evaluates to false. Once again, I skip the loop because positive is still 2, and I go to letter E. Same thing happens. E gets value of -1. Right is at 2 at the moment. Positive is still positive, so we don't go into the while loop. I hit the letter B. I decrement value in the map. I decrement positive also. Right? Because now I hit the 0 with letter B. Now I move right to 4. I hit letter A. I subtract. I hit 0. So I subtract from positive. And then I say, while not positive, I get into this loop. Length equals right minus left, 4 plus 1, 5. And where was it, len? Len equals 5. Len is shorter than best len, so I update best len to 5 and best left to left. Well, it's still 0. Right. So now I look at left. I try to remove, I look at frequency of letter C, right, S left. It is 0. I am about to remove this from the substring. That would increment what I need. So I increment positive. I increment frequency in the map. I increment my left. I go back. Is positive 0? No, it's no longer 0, so I break out of the while loop.
Okay. So this part, not something, is true only if this value is 0.
Right.
Okay.
And later it becomes positive. So
Okay.
we can only get within here if it is a character from T. Other characters they will never affect pos, because pos counts positive values. Character that is not in T cannot have a positive value. Right, so we proceed. We add n. Well, we move right. We add n. Now n has value of -1. We add c. We move right to 6. We add c. Well, the way we add it, we first decrement the frequency, then we check, is it 0? It is 0, so pos is now 0. We go into the while loop. Length equals 6 minus 1, 5, plus 1, 6. So it's actually not good enough, because we have now this string, O, E, B, A, and C. Right? It's too long. We don't update this. But we look at first character. Can we remove it? It's letter O, right? Is its frequency 0? It's not 0, so we don't do anything to pause. We increment this frequency and move left. We go back to the while loop. Oh, it's still 0, right? We removed characters that we did not need. So we keep going. Now length is 6 minus 2 plus 1. Length is 5. It corresponds to E bank, right? It's still not smaller, so we don't update anything. But we look at second letter, which is E. We think, can we remove it? Is its frequency 0? It is not, so we don't increment pos. We increment the frequency, so it's now 0, and we move left. Left is now at 3. Pos is still 0, because we removed once again a character that we did not need. So we continue in our while loop. Now length is actually 6 minus 3, 3 plus 1, 4. So now we update best length to 4 and best L to 3, right? We look at the frequency of S left, which is this. It is 0. Right? We had just enough, and we are about to remove this letter. So obviously it will be bad. We will have one more unique character that we need to address. So we increment pos, we increment the frequency, we increment left. At this point, pos is finally 1, so we break out of the while loop. We increment right, right gets to n, so we end the for loop as well. We look here. Best length is 4, it is not 8. So we return the second part. This is like return this if this else as best something. It is a ternary operator. So we return substring starting at 3 of length 4. 3 is B, length 4 is bank. So we return bank, which is supposedly the right answer because I don't see a shorter substring.
It is for sure the correct answer. Okay, it's great. I was thinking maybe we could do quickly a short example with duplicates. I don't know, let's say A, B, C, AAB, AC, and would be S, and T is say AA. Something like that. Just quickly to go over different cases.
All right. So we start with what? Pos is 0, counter. We look at letter A. Is its frequency 0? It is. So we now have one more distinct character to worry about. Then we increment the frequency. We go over another letter A. Is its frequency 0? No, we already have seen it, so we don't touch pos. Then we increment this frequency. These assignments happen. Right starts at 0. We look at S0. Decrement its frequency. It is now at 1. Is it 0? No. We still need this character, so we don't touch pos. While pos, don't go into it. Next, right equals 1. This is character B. Decrement the frequency. B is now at -1. Is its frequency 0? No, don't touch pos. Pos is still 1. Don't go into the while loop. Right is now at 2. S right is A. Decrement the frequency. Well, now it's at 0, so pos gets decremented to 0. While not pos, go into it, length. 2 minus 0 plus 1, 3. Makes sense, because we now have string ABA. Is 3 shorter than best len? Well, it is, because best len was just some sentinel. So we update best len to 3, best L still 0. Just so happened. We look at S0. It is A. Its frequency is 0. We had just enough of A. Now we are about to remove it, so the number of distinct characters will increase. And frequency increases, left increases. Pos is no longer 0, break out of the while loop. Right gets to 3. Decrement the frequency of C. C is now at -1. Is it 0? No. So don't touch pos. Don't touch pos. Pos is 0. No. Don't get into the while loop. Increment right to 4. 4 is equal to 4. Break out of the for loop. Best length is 5. No. So return this. From 0 as character, 3 characters, ABA.
Yeah, great. Looks good. I think it must be correct. We can, if you want, we can copy paste it and run on other test cases.
Please do.
I mean, I can. Should I send you the link, or should I do it on my site just to make
yourself?
Okay. Let's pretend that I solved it.
Oh, you are worried about that. Yes.
Yep, it works. It works quite well. It says that it beats 63% in runtime and 50%.
The runtime is probably very small in absolute terms.
Well, if you want, I can share my screen to quickly show the statistics.
No, doesn't matter.
No?
Like these numbers, they mean nothing really. Like just.
Yeah, that's true.
Whatever.
But was fast. It's correct. So it didn't fail anywhere.
Yeah, it's like 20 milliseconds. So the difference between 10 milliseconds and 20 is the measurement error from the LeetCode side.
Yeah, probably.
Okay.
Yeah, so it went great. Do you think it makes sense for me to give the feedback? Because it's going to be just everything was great. But I can also go over the form if you think it's gonna be useful.
No, not really. I think we can continue in Ukrainian now, probably. It's fine.
Listen.
Що я думаю? Я думаю, я дуже багато часу витратив на всі ці неоптимальні розв'язки. В принципі, задача hard, тому я розраховував, що час у мене є. Так? Але щось з цього можна було скіпнути при бажанні. От. Що ще я думаю? Трішки наплутав дійсно з плюсем, але то таке. В принципі, тут можна якийсь чек дописати в стилі, якщо m більше за n, то return порожній рядочок. А інакше m менше рівне, ніж n, і його можна в асимптотику не писати.
Ну, та в умові тут не стоїть, що n буде менше за n, тому теоретично так.
Так, добре. Що ще можна тут сказати? Отут у нас цей unordered map, так, це хеш-таблиця. В принципі, у characterів є ASCII-коди, тому тут можна було б використовувати масивчик розміру 256. От, у масивчика константа краще, ніж в unordered map. То це міг бути array int 256. Не знаю, наскільки це допомагає, але про це я забув сказати. Його треба тільки не забути нулями заповнити. Так, ну а це виграє трішки часу. Якщо взяти масив і його заповнити нулями. Що ще можна сказати? Оце трішки незвично, що у нас тут, типу, T з плюсом, S з мінусом, можливо, краще було б в іншому порядку написати. Ну, вже як почали, так написали. Чек ось цей на порожній рядок. Його можна було винести окремо, сказати, типу, одразу порахувати всі фріквенсі в S. Так? Ну, типу, взяти весь рядок. Якщо весь рядок не підходить, то видавати порожній рядок. Можливо, це також виграє по константі. Що ми одразу перевірили, підходить чи не підходить. Більше я не знаю, що про цю здачу розказати. Ну, це якась класична задача. На слайдинг window. Давно на слайдинг window не було, тому я, в принципі, не проти. Може, ти ще щось помітила? Я розумію, що з C++ складно. Python девелоперу, але...
Та ладно, вже можна було так не уточнювати. Ну, до речі, не настільки все і погано. В принципі, мені здавалось, що C++ буде важче читати, але ну, код добре написаний. І я розумію навіть як Python девелопер.
Я використовую цей прикол з ініціалізацією. Це насправді те саме, що ось це майже. Коли ти бачиш, тут написано дорівнює, а тут фігурні дужечки. Тому що якщо ти пишеш фігурні дужечки, то це ініціалізація, а тут не відбувається ніяких неявних приведень типів. А тут відбувається. Оце, наприклад, беззнаковий тип, а ось це знаковий. Беззнаковий, тому що ленс просто повертає такі. В C++ сильно типізована мова, тому з цим є свої приколи. Наприклад, треба казати, з кого куди у нас unordered map. Так, що дікт з чарів в інти, а не просто якийсь дікт. Ну, це не дуже складно. 2 слова написати. А решта так, плюс-мінус відповідає Python.
Ну, рятує те, що немає всяких поінтерів. Але от я не знаю, наскільки це часто відбувається на літходівських задачках, що треба поінтери
Ну,
використовувати.
тільки на якихось зв'язних списках або двійкових деревах.
Угу.
Ніде, ну майже ніде. Ну, майже ніде не треба.
Угу.
От.
Так? Ну,
Добре, може
ну, супер, так то зрозуміло. Загалом, що ти зробив. Ну,
Тепер
навіть не загалом, а покроково зрозумів.
Ну, простіше було, можна без поз здавати здачу. Так, ти просто робиш ось так, ось так, ось так, а тут якийсь чек, просто пройтися по всій мапі.
Угу.
Тобто це от той множник від alphabet size. Якщо з поз складно, то без поз на 4 рядочки коротше, але тут чек за 52 операції виконується потенційно.
Угу.
От, ну все, напевно, тоді будемо розходитися, вже у всіх пізно. Перепрошую, що так затримав. Ну, я попереджав, що це може затриматися. Ну, зі свого
Нічого
боку.
страшного, це корисні штуки дуже. Тому я рада на такі речі не втрачати час. Це
Добре.
називається інвестиція.
Я тоді запис зупиняю. Так, там можете прокоментуйте, якщо вам є щось прокоментувати, а ми вже далі самі поговоримо.